5/6 about the fundamental theorem of algebra. What that states, in a sense, is that the biggest power, which is 5, means there's 5 roots. Whether real, irrational, imaginary, whatever, but there's 5 roots. So again, when I punch this in my calculator, it'll spit back some answers. Okay? Well, what's it going to tell me on this one when I get it? It's going to give me 1, 2, -2, I, and -I. Again, that follows the conjugate. Once you know you have I, you know it's going to be -I. Okay? And that's what your calculator will give you. Hence the 5 roots and the 5 power. So again, here, what are all the zeros? Sometimes it's not going to give you all 5 rational roots that are pretty that look like that. So I have to kind of manufacture them. So I punch this in my calculator. It's going to give me 2 rationals, in fact, and it's going to give me some long decimals with an I. I can't use those as my answer. Okay, so what I have to do is I have to take the 2 rational ones that I get. So punch in my calculator, and the 2 it's going to tell you are 3 and -3. Now, how can I get the other 2? Because again, we look at the top number, it's 4. It's got to be 4 roots. Okay, well, I've just taken one and just synthetically divided. It doesn't matter which one you start with. They'll both work. So you get 1, 1, -7, -9, -18. Bring the 1 down. 3 times 1 is 3. Add 4. 3 times 4 is 12. Add 5. 3 times 5 is 18. 15. Add, you get 6. 3 times 6 is 18. That gives me 0. Again, to be a function or to be a root, remember the remainder is going to be 0. So that double check to make sure that 3 is a root because it gave me 0 as a remainder. So I'm still left with this polynomial. It is not a quadratic. Now, like I was saying, this is not a quadratic because it has 4 terms. It has 3 terms. That's usually what a quadratic is. And again, we start at x to the 4th. We divide once, it becomes down to x cubed. So I've got to use the other root that it gives me and synthetically divide again. Now, the remainder is gone. If you want to put a box there, whatever you want to do, just to make sure it's gone, you don't have to worry about it anymore. Bring the 1 down. Same thing. -3 times 1, -3. Add, you get 1. -3. Add, you get 2. Multiply, you get -6. You get 0. And there's your remainder. Now, here's your quadratic. So again, this is x squared plus x plus 2. Now, you don't have to really represent this as this quadratic. That first one is your A. The second one is your B. This third one is your C. So again, we talked about this before. How do you solve? Well, quadratic formula. So -b plus or minus the square root of b squared minus 4 times A times C all over 2 times A. Punch that in your calculator. 1 plus or minus the square root of -7 all over 2. Again, once I have the negative underneath the radical, what do? I pull the I out, leave the square root, and I would reduce from here if I could, but again, I don't really need to. So here's 2 of my roots, and here's the other 2 of my roots that compile to make the 4 roots.